My name is Alexei, and I'm CEO of Zingaya. I'm here today with our CTO, Andrei. And we participated in WebRTC Expo a year ago. And this time, we showed our click-to-call technology for customer service and sales. So it's our first product, and we've been working in real-time communication space for the past 5 years. And at some point, we decided that WebRTC is a great new technology, is a game changer, and I guess everybody in the audience agree on that. But it's still like, it simplifies a lot of things for people like us who are familiar with real-time communication apps and services and its development. But there are still a lot of scenarios when you don't need only peer-to-peer call between two browsers, or you need something more complex like sending a call from WebRTC to SIP, or to receive call from PSTN in WebRTC client, or do some video conferencing things like we saw a lot of demonstration about video conferencing this day. We started looking at different platforms for developers available on the market, and we saw that all of them were using the same approach. They were using REST API that allowed developers to create different communication apps and services, having HTTP communication with some platform in the cloud, and you still needed to create some server-side scripts, host them somewhere in your infrastructure. It was not flexible enough for a lot of scenarios, and that's why after we created Zingaya, we decided to create a platform for developers as we see it, and we created and launched WorksImplant, which is a platform for developers, for people who would like to embed real-time communication functionality inside existing or new mobile applications, web applications, for people who would like to integrate telephony with existing interesting scenarios like CRM, cloud IVR, etc. So how we are different from other platforms on the market, like most of you probably heard about companies like Twilio, Plivo, and others. So we decided that there are a lot of JavaScript developers. So all JavaScript developers building something for browser using WebRTC nowadays. And there is a big shift when JavaScript developers can build things for server-side as well. So we all know about servers like Node.js, Socket.io. And we decided that it's a great thing to offer JavaScript developers an option to create call control logic deployed somewhere in server-side. And then, it's like front-end developer can create the whole thing. So he can create the server-side logic, client-side, integrated with some existing backend, so you don't need expensive backend engineers, and you can build really cool apps really fast. So Andrei will show you our Cloud App Engine scenarios editor. So you can write scenarios using our code editor right in the web browser. So we got some good editor here with autocomplete functionality. So we're just using JavaScript to write some scenarios here, and then you deploying this scenario in the cloud. So it's not only about routing calls through the platform, it also allows you to make HTTP requests in real time to integrate it with existing backend and some other logic, like send email or SMS or do something else. So it's really flexible. So it's up to you what you can implement there. It really depends on your business needs. After we created some application and deployed it in the cloud, we can forward the call through this cloud to some web application according to the logic we created. So for example, we created a simple mock-up of Salesforce application. So I can call to a phone number connected to our platform. I don't know. Let's see how it goes. So.
Hello, you have called Vox Implant Demo. Please wait while we transfer your call.
So we reached our platform. It actually, from server side, made a HTTP request to Salesforce backend. Then we could get data using caller ID we could get from a call. Then we send this data together with the call to the browser and show some information to the sales agent in Salesforce. And this kind of scenario, you can create it like in a few minutes. So it's really easy to do that. Every web developer can spend some time figuring out how Salesforce API works and how Vox Implant, SDK, and API works, and our Vox engine, which is a cloud app engine. And that's it. So you can create this type of scenarios. But most of us know as well that it's not only about developing apps. You spend a lot of time debugging these apps you develop, because you always have some problems somewhere, so you need some time and convenient tools to debug your application. So we created a cloud-based remote cloud debugger thing, so you can debug these scenarios right from your browser. So if I call to the same number, call will be routed through our platform, but our debugger is connected to the session. So, okay, so here we see that our call reached the platform, and we had some breakpoint here. So you can go through the script, like using step over function, see some watches there. We got call stack, breakpoints, everything you see in familiar tools like Chrome DevTools or Firebug or others. So developers can build communication apps on server side in the same way they build communication apps using WebRTC on client side. It's really fast and easy, and it's kind of very efficient tool for front-end developers. So another thing we would like to show today, in addition to our platform, is one interesting feature of the platform we've been working on. It's more proof of concept rather than kind of in production state. So Andrei will tell more about it.
Yes, I would like to talk about video calling. There are a lot of discussions for past year about mandatory video codec for WebRTC, and decision still hasn't been made, and we have no idea when it will be actually made. But everybody wants to have video call right now, and the only option that is available to WebRTC developers is VP8 codec. Well, this codec isn't supported by most of SIP infrastructure that already is deployed, and there are a lot of such devices. Video conferencing devices, video phones, and so on. And so the only option available for developers is transcoding, which is, as we all know, is very, very heavy operation that consumes a lot of CPU power. So we decided to dig a bit deeper and found out that VP8 and H.264 have quite a lot of common things, and we used that fact to create our converter from H.264 to VP8. It's not actually transcoding. We do not reconstruct the whole picture, and we do not perform any analysis on this picture to encode it to VP8. So let's see how it works. I have a Chrome browser with VP8 support, and I call a Bria soft phone which has H.264 support. So I make a call. Here it is on the iPad of the Alexei. He answers, and we can see that picture is here. It is still proof of concept, so the quality may not be the best one, and the performance is not the best, but even now it is comparable to, for example, FFmpeg, which is actually quite good. And we expect it to be like 3 or 4 times faster than that, or maybe even 5 times. So this technology will give developers an opportunity to integrate WebRTC with existing SIF infrastructure for video calls, and not being afraid of huge machines they have to deploy to perform video transcoding. Oh, sorry, it's again. So that's it, I believe.
Yeah, so Andrei forgot to mention that this conversion in real time right now was using a proof of concept library written in Java, and it's already as fast as FFmpeg written in C, C++, and even assembler. So we have kind of a lot of things to do here to make it better, but we think that we will be able to do that with help of our partners, and we are working on that. So expect to see some kind of conversion instead of transcoding in a few months, I would say. So that's it. That's all our demos for tonight. Thank you.